I want to start out just by giving a little bit of a reminder about your pesticide license. So when you came in, you signed up, signed this sign-in sheets there. Each program has a program number, so that's that number up there at the top. And I also gave you a receipt. So you've got a receipt, hang on to that, that's your proof you've been to the program. Every county does it a little different, so every receipt you get is going to be a little bit different. I use those half sheets. It's got the date, name and the date of the program number, the fact that you paid your $10. So if there's ever an issue with a program not showing up on your record, if you've got that receipt, when you talk to the state chemist office, it makes it a lot easier to figure out. Because if you've got that receipt and I've got you on the sign-in sheet, they're going to give you credit for that program. So just a couple of reminders then. Your license is good for 5 years. During that 5-year period, you have to attend 3 recertification programs. So recertification programs like this, field days, some of our winter programs that we do, we have PARP credit there as well. If you do have the Category 14 fertilizer applicator's license, that counts for the same, for private applicator. So you can't attend more than 2 programs in 1 year. So basically you can't do all 3 in 1 year. You can get 2 of them in 1 year, but you can't get all 3 in 1 year. And then there again, just be sure and keep your receipt. So tonight's topic is one you may have heard. We've covered it a few times over the last couple of years, but I thought it'd be a good one to revisit this evening. It's our Be Aware pollinator awareness talk. And basically here we're just stressing the importance of taking into consideration the pollinator populations when we're making some of these pesticide applications. I don't think anybody would argue or disagree that pollinators aren't important to us. In fact, if you look at this slide, 80% of the flowering plants in the world require some type of animal pollination to grow, reproduce, and produce seed. So that provides, food for wildlife, but then also, food for us. A tremendous amount of the food that we grow, produce, and eat depends on pollinators to grow, basically. And it's not really just an environmental concern, it's an economic concern as well. As you can see up here, the value of these crops that depend on pollinators is pretty significant. Almost 20 billion in this country alone. Worldwide, over $200 billion in value of crops that depend on pollinators to be able to grow those crops, basically. And you can see, your breakfast dish up here, how that would differ if there were no pollinators to do that job. So if you like bread and granola and eggs, you're in good shape. But if you like to have a little fruit, jelly, and things with your breakfast, we need those pollinators. So when we think about pollinating insects, most people's minds automatically go to honeybees, and with good reason. Honeybees basically are responsible for a majority of the commercial crop pollination that goes on. They're very efficient. They're an insect group that are easy to manage by humans, so that's why we have people that are beekeepers and keep hives and move hives and things like that. But we also have hundreds of other species of native pollinators as well that do the same job that we want to be concerned about as well. And you notice I said native. That's another common misconception about honeybees, is that they're native, and they aren't. They came from Europe. They were brought here by European settlers. But before that time, there were not honeybees in North America. So all of the pollination depended on these native pollinators. And that includes other bee species like bumblebees, but also other insect species like butterflies, beetles, different types of other different types of flies, and even wasps. Not only the big, paper wasps that we think of and we get stung by this time of year, but there's lots of other species of really small, tiny wasps that do a lot of pollinating for us as well. So even in Indiana, our list of crops that are dependent on pollinators is pretty significant. It involves, or it includes tree fruits like apples and pears and peaches, small fruits like blueberries, raspberries, strawberries, blackberries, all of those are dependent on pollinators. And then our cucurbit crops, melons and cucumbers and squash are all dependent on these pollinators. So like any other insect, the populations of these different pollinators go up and down. They go in cycles. There's nothing unusual about that. But what is concerning when you look at pollinator populations, honeybees and other native pollinators, when you look at that, their cycles over long term, we're seeing slow long-term decline in their populations. And we don't really know why. It's not really been pinned on one single reason. A lot of people are quick to point the finger at pesticides. Well, it's just all the pesticides that are being used. And other people are quick to respond back, well, it's just natural diseases and parasites and things like that. Well, basically it's a combination of these things. Parasites and disease are an issue. Pesticide use is an issue. Lack of habitat, lack of food source is an issue as well, and likely a contributing factor to this. Our corn and soybean fields across the Midwest are not pollinator habitats. The standard American lawn with our green grass and our hardwood trees is not adequate pollinator habitat and adequate pollinator food sources. So we want to keep that in mind as well. So we do know that pesticide use is a contributing factor. So it's important as pesticide applicators, both in the ag field as well as home, lawn, and garden situations. It's important that we understand how these products harm bees, which ones have the most potential to harm bees. It's important that we recognize how bees and other pollinators work, how they move, how they forage. And then it's also important to become familiar with the products we're using and know their potential for toxicity to bees. So, we think about pesticides. Like I mentioned earlier, a lot of people like to point the fingers at pesticides, but the fact is most of our pesticides that we use in agriculture are not toxic to bees. The ones that are generally fall into the insecticide category, but even within the group of insecticides, not all insecticides are toxic to bees either. So we want to make sure we know which ones are, know how to use them, and know the potential effects that they can have. So we've got two main ways that pollinators can be affected by these pesticides. And the first one is direct exposure. So that just means that if you've got a crop or weeds in a field or in a garden or anywhere else that's blooming, and you apply an insecticide that's toxic to bees, and those bees die because they've been come in contact with that product and they die, that's direct exposure. The other way, though, that's also a big concern with these products is the residuals. So a lot of these insecticide products stick around. They have residuals. They remain in the field on the surface of these plants anywhere from a few days to a few weeks, and that's the ones we're really concerned about, and really need to know more about the products that we're using so we know whether they fall into these categories. So again, this residual toxicity is what we call that. It just means that those products remain on the plants after the application. The pollinators come back, forage on those flowers, take that product back to the hive, and then you end up infecting the whole hive or the whole colony. Within those residual toxic products, there's another category of these that we call extended residual toxicity products. Those are the ones that last a really long time, stick around for quite a while. And these are the ones that we're most concerned with. In fact, these are not to be applied to crops that are in bloom, and we try to avoid their use in areas where there may be pollinators on field edges or adjoining crops that might be in bloom as well. So what are these products? Well, they're pretty common ones and some names you'll recognize. Organophosphates, such as malathion, is an extended residual toxicity pesticide. Carbamates, including carbaryl. Does anybody know what carbaryl, the brand name of carbaryl is? Sevin. Sevin is probably the most overused and misused product in the home, lawn, and garden. It's a very effective product, a very useful product, but very toxic to bees. The neonicotinoids, those are common in both lawn and garden settings and in ag settings, in like seed treatments and things like that. And then pyrethroids are another one that have this extended residual. So it's important when we're looking to apply one of these. I mean, it's not that we're saying you can't use those. I mean, there's definitely benefits to those products. There's economic benefits to those products. Sometimes we can't produce a crop without those products, but it's important to remember, how they affect the pollinators and kind of adjust our applications based on that. So it's important first then to understand the daily grind basically of a honeybee. So as you kind of look, they're starting at sunup, they slowly get more active. They're most active from about mid-morning to mid-afternoon, or late morning, I think, to mid-afternoon. So, in this peak period here of the day, that's when they're going to be most active. And as we get further into the afternoon, their activity drops off pretty quickly till sundown when they're no longer active. So when we look at that and then kind of start looking at the best time to apply some of these products on blooming plants, we obviously have this period in here in the middle of the day where we shouldn't be applying these products on blooming plants or if there's pollinator activity in the area. The best time then is right after sundown, where they stop their activity for the day. And even, if you've got products with a small amount of residual, even through the night, from dusk until dawn can be a proper time to apply. But then we kind of start again, in the morning time, cutting off those applications again. So this is just kind of a general chart here. Your pesticide label is going to give you a little more specifics, but keeping in mind that for these products that do have effects on pollinators, that best time is kind of right at and after sundown. So again, we mentioned already just having products or crops in bloom, keeping that in mind. Consider using products that have a short residual if you do have products or do have crops in bloom that you're applying to. And again, we're not applying any of these extended residual toxicity products on plants that are in bloom. The label is an important source of this information, just like any other thing that we get off of a pesticide label. So it's important to understand that, understand what the potential harm to these pollinators is, and take some time to read these labels, understand this before you go out to make your application, so that you do understand and know how you might have to adjust your application. Fairly recent addition to pesticide product containers is this EPAB Advisory Box. So you look for this little B symbol here, and it spells out the toxicity level to pollinators, how to apply it to reduce that risk, information about minimizing the exposure, times of day to apply, and things like that. So basically, they've compiled that information in an easy to locate area on the product. So you have to look for that little B emblem there, that B icon, to find that information. So there again, just taking some time to read the label is important. A few questions to kind of think about as you're planning to use that product and planning to make any applications on your crops. Just understanding the life cycle of your crop, understanding when it's going to be in bloom, understanding when it may need treatment, and then kind of trying to adjust your treatment times to have the least amount of effect on pollinator populations. It's also a good idea to kind of know what's surrounding your field. If you've got ditches or fence rows, grassy areas surrounding your fields, knowing what's in there as well. Blooming cover crops or blooming weeds may also be an attractant to pollinators as well, so keeping that in mind. Knowing what pollinator activity is nearby, knowing what adjacent crops you may have. If you do have vegetable or fruit crops nearby that you need to take into consideration as well. So, all of these things are things to kind of consider when you're looking at making an application. And then it just comes down to developing an integrated pest management plan, just like you would for weeds, just like you would for disease issues, where you're trying to use a variety of tools beyond just chemical controls to control an insect problem like this. Only using the pesticides when they're needed based on threshold levels and all that. And you do that by scouting and monitoring the crop. And then when you do have to use pesticides, obviously take the steps you need to take to prevent any drift from the field and from your intended crop. So then I just want to close here with talking just a little bit about, we've talked a lot about honeybees. So how do you know when somebody has honeybees, or how do you know if somebody's got some hives at the edge of their property that might have joined your field? Well, we've talked quite a bit over the last few years about the DriftWatch website, which is a database website where growers of specialty crops can register their locations. You as applicators can go on that site to find those locations and make sure you know where they are when you're planning applications. That website has a beekeeping section. It's called Bee Check. So as applicators, you can go on there and locate beehives that may be in areas where you're planning to make applications. Now, this is only good as as good as the information that's put in there. So if someone hasn't entered their hives in there, obviously you won't know that they're there, but it is a good idea to check that site and know where those locations are.